In panel C of graph 19.6, we illustrated how the deadweight loss from a wage tax appears on the compensated labor supply curve, even as the uncompensated labor supply curve is perfectly inelastic and hides that deadweight loss. We'll illustrate this here once again using some underlying mathematical functions and show how it relates to areas underneath functions, even though we usually illustrate these as areas to the left of curves. The compensated labor supply curve only incorporates the substitution effect, which always says that as the wage increases, a worker chooses to work more. Thus, the compensated labor supply curve is upward sloping. This particular curve is derived from equation 19.26, where we've assumed a leisure endowment of 60, alpha of 2/3, and a post-tax utility level of 193.1. The underlying Cobb-Douglas taste that we've assumed implies that this worker will always choose to work 40 hours per week. In other words, the uncompensated labor supply curve is perfectly inelastic. Since the compensated labor supply curve we drew is evaluated at the after-tax utility level of 193.1, the two curves cross at the after-tax wage of 15. Given the wage tax of T equal to 10, the before-tax wage is equal to 25. Since the labor supply curve is perfectly inelastic, the entire burden of the tax is borne by the worker, with the worker experiencing a decline in the take-home wage exactly equal to T. The areas A, B, and C are then labeled exactly as they were in graph 19.6 panel C. The deadweight loss is equal to area C as explained in that graph. We then invert this picture to illustrate supply functions instead of the supply curves from panel A, with the areas now becoming areas beneath the functions as opposed to areas to the left of the curves. The magenta line is now equation 19.20 with alpha set to 2/3 and capital L set to 60. And the blue curve is equation 19.26 with L set to 60, alpha set to 2/3, and utility set to the post-tax utility level of 193.1. It's often easier, particularly when tastes are not quasi-linear, to simply use the expenditure function to calculate the deadweight loss area C. This is done in equation 19.25. But it can also be calculated as the integral of the compensated labor supply function between the before and after tax prices with the area A subtracted from it.